Welcome to GeoOmega Virtual Learning. In today's lesson, we'll be talking about cubic graphs. Please subscribe to the channel and share with your friends. Hit the notification button. In this lesson, we'll learn how to draw cubic graphs and also how to estimate solutions from cubic graphs and how to sketch cubic graphs. Let's first have a talk about features of cubic graphs. Cubic graphs are generally of the form y equals ax cubed plus bx squared plus cx plus d. The d is the intercept, the constant is the intercept. It's cubic graph because the highest power of x is cubed. So it doesn't necessarily have to have all the four terms. You could have any combination, but the highest power of x has to be a 3 cubed. These are examples of cubic graphs. So let's look at these drawings and see how we can explain some of the features. Let's look at the first graph. Now, whenever the coefficient of s cubed is positive, this is the shape of the graph. It doesn't necessarily have to be the same axis, but I'm talking about only the shape. The shape should be of this format: up, down, up. And whenever you have a positive coefficient of s cubed and you have up, down, up, you're going to have two turning points, the maximum and the minimum. This is the maximum point because the y value increases to a point, get to maximum, then start decreasing, gets to minimum, and start increasing again. So we call these turning points. This maximum turning point, minimum turning point. Then for this particular graph, the solutions, whenever we say solutions of the graph, is where the y is equal to 0, or where the line cuts the x-axis. So solutions are where y equals to 0, or where the line crosses the x-axis. And there are three solutions: 1, -3, another one is +1, another one +2. So for this particular one, the solutions are 3 values, and the intercept is +6. Let's look at the second one. As you can guess, if the coefficient of this is positive, what do you expect this to be? Of course, negative. Also has turning points, but this time is what? Minimum first before maximum. Minimum turning point before maximum turning point. And the solution for this particular one is only 2. One at this point and one at that point. So it's not always that has to have 3. Depends on the kind of function. So this has only 2, and the intercept is +2. Now sometimes you have cubic graph which is of this form. It could be the other way around as well. Now, when it's this form, remember, you start from the top first, so it's also when a is negative. This is also when a is negative. Even though it doesn't go up and down, but it's still, if you look at the way it starts from the top down, this is where a is negative. If a were to be positive, it should be the other way around. Now for this one, we call it point of inflection, because at that point, you can think of rotating it 180 degrees and it will still look the same. So we call this point of inflection. It doesn't come down and go up, so we call it point of inflection. So this is a simple talk about the features of cubic graphs. Now let us go into the real drawing of cubic graphs. And of course, the intercept is 0. So we have y equals s cubed plus x minus 2. You must know how to set the calculator right to make sure you don't get wrong values, especially for the negative x coordinate. So the calculator should be set up such that all the x values must be in bracket. So if you want to try the first one, it has to be -2 cubed plus, into bracket, -2, then -2. And that will give you these answers. So try and see if you can get the same answer. Then from there you plot them as normal coordinate: -2 and 12, -1 and 4, and so on. Then you join with a smooth curve. That's our graph. Let's do some checkpoint to see if everything is right. The intercept is -2, right? The coefficient of x cubed is positive, so it should be this format, yes. And this one is also the point of inflation one, like this. Now, we are supposed to use the graph to find the solution for the graph x cubed plus x minus 2 equals 0. If you look carefully, this expression is exactly what is here. So that means that we are talking about when y is equal to 0. And like I said, the roots of the equation or the solution of the equation or function is always where y is equal to 0. So you draw a line on where y equal to 0 and where it cuts the graph. It cuts the graph at one point, so the answer is 1. The answer is x equals 1. It depends on the shape of the graph. You could have 2, you could have 3, you could have 1, sometimes even none. That is when the graph doesn't have a real solution. But this one has 1. Let's look at example 2. Also, similarly, set your calculator right. It's a negative s cubed, so negative should be outside the bracket. You set the calculator such that negative is always outside the bracket, and you put in the values of x. This is how it's going to look like. So only the values of x should be in the bracket. So the first one will give you -2, -2, -2, 0, 2, and -2. Let's plot. Join with a smooth curve. So that is our graph. We are supposed to use the graph to estimate the solution for the equation -s cubed plus 3x equals 1. Let's check. -s cubed is the same as -s cubed here. 3x is the same as 3x here. So we are saying if this represents y, then we can comfortably say the whole thing here, y is equal to 1. So we are supposed to draw a line, y equals to 1. Then from there we estimate our solution. And that is the line y equals to 1. And it crosses the graph at 3 points. Then you read your values on the x-axis. So x is -1.9, x is 0.4, and x is 1.5. So these are the 3 values. It's an estimate, so that would not give you the exact value. So we are using the graph to estimate. So these are the values for x. Then we're supposed to find the minimum and the maximum turning point. As for the minimum turning point, like you can see, the flashing point tells you the minimum value of y. That's the minimum turning point. So the coordinate of that point is -1 and 2. Then the maximum turning point is also the flashing point here, which is 1 and +2. So this is how we work out the minimum and the maximum turning points. So far we've learned how to draw cubic graphs. Now, how do we sketch cubic graphs? So most of the time you'll be given the function and you need to find a way to know your intercepts and sketch them. So to sketch cubic graphs, I'm going to go through 3 steps. The first thing to do when the function is given of this format is to find out the intercept by setting y equals 0. So you want to know the values on the x-axis. You do that by setting y equal to 0. So if y equal to 0, it means x plus 3 equals 0, or x plus 1 equals 0, x minus y equals 0, and so on. You work out the values. So x plus 3 equals 0 will give us x will be equals to -3. This bracket will give us x -1. This bracket will give us 1. These are the roots of the equation, or in simply terms, the point on the x-axis that you need to mark. So we know our roots for the equation. Step 2 is to get the y-intercept. You get the y-intercept by setting x equals 0. The first step is y equals 0 to find x. Second step, x equals 0 to find y. So if x is equal to 0, this is what you have. All you have is 3 in the bracket, 1 and negative 1, and you multiply. That gives you negative 3. So I now know my roots and I know my intercepts. So I'm going to do a sketch. On the x-axis, I need to mark negative 3, negative 1, and 1. Done. On my y-axis, I need to mark negative 3. Also done. Then remember, x times x squared times x cubed is a positive s cubed. So that suggests a graph of this format. So you need to check. So that's a positive coefficient. Then think of it. How do you draw the graph through all the 3 points and the intercept? You need to practice these. Once you keep practicing, you will know how to draw them. So this is what it's going to look like. So that is a graph. So you have your intercept, negative 3. It's a positive graph, so it's up and down and up. Okay. Let's look for another example. So we have x plus 1 all squared, then x minus 3. Step 1, set y equals 0. So what I've done is x plus 1 all squared. I've written it twice because it's squared. So you can see it's twice here. And when that happens, you're going to have what we call repeated solution. X plus 1 will give us negative 1. X plus 1 will give us negative 1. X minus 3 will give us 3. So we call it repeated solution. And whenever you have a repeated solution, your graph will turn at that particular point. So that's one thing you need to remember. Repeated solution will mean that when you draw the graph, it's going to turn at that point. Step 2, find the y-intercept by setting x into 0. Setting x to 0, that is 0, 0, 0. You're going to have 0 plus 1, 0 plus 1, 0 minus 3. So 1 times 1 is 1 times minus 3 is negative 3. So our roots is negative 1 and 3. Let's plot that. Our intercept is negative 3. Also, x squared times x is positive x squared. So it's a coefficient of x squared. So s cubed is positive. Coefficient of s cubed is positive. So the graph should look like this. But remember, this turning point, the first turning point, should be on negative 1. So the flashing point is reminding you that the turning point should be here. So how will you draw that? So this is how the graph is going to. So this drawing, you get used to it when you keep drawing, practicing how to sketch. So this, the graph, how to sketch this graph. Let's look for another example. Here, set y equals 0. You got your values for the root of the equation. So we have negative 1, negative 3, and 1. It's 1 here because 1 minus x equals 0. X has to be positive 1. Set x equals 0. So you're going to have 1 times 3 is 3. 3 times 1 is 3. So it's positive intercept. Let's plot the points. Negative 1, negative 3, and 1. Negative 1, negative 3, and 1. Intercept 3. Right. Now, remember, x times x is x squared. 2x squared times negative x is negative s cubed. X times x, as you can see from here, is x squared times negative x. So this is a negative s cubed. So you're going to do a graph that's going to be of this format. So you need to be checking all these things before you start drawing them. And you just draw them. So that's how it's going to look like. Let's look at the final sketching of cubic graph. Now here, we've not been given the function in a factored form. All the 3 examples, the function is given in a factored form. This one we've not been given in a factored form. So we need to start by factorizing. So you factorize to help you understand what to do. Okay. So we factor before we set that. So when you factor out x squared, you're going to have x squared into bracket x minus 2 equals 0. So we set it into 0 to find out our roots. Now x squared means x times x. That's why I've just split it into 2 for you to understand. So one x will be equal to 0. The other x will also be equal to 0. Then this x minus 2 equals 0 will give us positive 2. So we still have repeated solution. And our 0 is going to be our turning point. Now, step 2, set y equals 0. And you can see there's no intercept. So it's even easy to do that. There's no intercept. So the intercept is still 0. So let's plot roots of the equations 0 and 2. So 0, 2. Intercept is still 0. And it's a positive coefficient, so it has to be of this format. 0 is a turning point, so draw it as a turning point as it's flashing, and that's done. So this is how we draw quadratic graph and how we sketch quadratic graph. And that ends our lesson on cubic graph. That ends our lesson on cubic graph. I hope you've enjoyed this lesson. Subscribe to this channel and share with your friends. And pass any comments as to what could be done to make this better. Thank you very much.